read CSV, read from a Parquet file. We have to talk about regular expressions, loc, iloc, @, and the shorthand notation. So in apply, instead of defining a new function, you can use something called Lambda. Just like in SQL, we can perform joins. Here also we can combine multiple data frames. This also supports inner, outer, left, right joins. How can we detect the null values? And then we will talk about how to handle the null value. So whatever was the mean of all the ages that we had, we assigned that. Find me the mean height for females and mean height for males. Data science is all about data. But often in real scenarios, the data that we have is first of all huge. We get massive amounts of data. Secondly, it's not usable. How do we get started with this huge amount of data? How do we make sense of it? How do we handle it? How do we clean it, structure it, analyze it? And you can imagine that every single project that we do, or in every single task that we have to perform, there would be some common things that we would have to do. For example, we might need to read from different kinds of files. We would need to read to different kinds of files, like for example, CSVs, XS, JSON. And if we are doing machine learning, we would often need to calculate mean, median, standard deviation, variance, and so on. Now, these are the common tasks that we have to perform. And do you think every single time I have to read from a file, do I have to write code for it? Do you think I will sit and write code for reading from file or writing to file again and again? Now you must be thinking, obviously, Keerti, there must be a library for it, which is good enough, and we can use its functions and data structures. Congratulations, you just understood the use and the purpose of Pandas. What is Pandas? Pandas is an open source Python library which provides us with data structures and functions which help us to clean the data, structure it, analyze it. So this is Pandas in one video, but of course, even with years of experience with Pandas, you would still be learning new things about the library. Having said that, let me assure you that here we cover more than enough things, all the important topics that are required for you to be able to work on most of the projects out there. Especially if you're getting started with machine learning, consider this as your prerequisite. You need to know Pandas to be able to get started. And I think most of the software engineers are now getting started with MLAI. This is going to be your one-stop solution. So don't worry about it too much. Everything is divided properly into timestamps. So if you are someone who is revising, you can just refer to that and let's get into it. See, there are many ways of writing code and learning Pandas. But if you are an absolute beginner who's just getting started, who doesn't want to spend time on installation and setup, you can just use Google Colab, which is on cloud, so you don't need to install anything. Plus, you will be able to store your progress and share it with your friends. Or if you have Python installed in your system, you can just do pip install notebook and get started with Jupyter Notebook. Or you could use VS Code, you could use PyCharm. There are many other ways as well. I'm going to be using Jupyter Notebook. It has a very basic setup, as I just told you. And I am also linking the notebook link over here, so you can refer to all the code that I will be writing. So it is present over there. It will be easy for you. Now let's get started with writing the code. Before we move it, I would just like to take a moment over here to share something with you. Over the last few months, I think all of us have realized that MLAI is the future. And that is why you're watching the video. It makes sense to read about it, to study it, and be future ready. And I've been doing the same. Over the last few months, I've spent so much time on MLAI. In fact, we have a product called TaxStop, which is currently live only for the Educosys students. But we are integrating a lot of AI stuff into it, and I'm learning so much over there. Also, we have been designing a live hands-on generative AI course. We have finally launched it. It's a 7 weeks course. You can check out the curriculum over here. It has 10 projects, some small, some quite big projects, but it is going to be completely live. And I'm just so much excited for it because here you will not only be learning about generative AI, you'll be building, deploying, and applying generative AI. The last hands-on course that we did was hands-on high-level system design course, which we call HHLD. That was MERN plus DevOps plus HLD. That is still one of the most enrolled courses on Educosys. I have seen so many students not only develop end-to-end projects, scalable projects, but deploy them and add them to their resume. It was one of the most satisfying things that I have done as part of Educosys, as a software engineer, as a teacher. That's when I decided I want to do more hands-on courses, and I'm really excited for this, and it's going to be live, so I hope to see you there. Like all the other courses, you will get access to the recordings, to all the future live batches, and you will get the access to code, notes, everything. You can check out the details, you can check out the testimonials of all the other courses, and I'm really excited for this. But for now, let's continue. I hope to see you there. For now, let's continue. Let's get started with writing our first code, and the first thing that we should obviously be doing is importing pandas, and the usual alias that is used is as PD. So in the code entirely, we'll always be using PD. It is very easy to use. Now to run this code, you can either just press this play button or you can just do shift enter, and we have imported pandas. Congratulations. There are two data structures that you should know about. The first one is called series, which is a simple 1D array. Let me show it to you. So if I create something called data and put some values 1, 2, 3, 4, 5 into it. Now see, this is a simple list in Python. Now you must be thinking that, Keerti, why do we need something called series? Why can't we just use a list in Python? The problem is that usually in machine learning, we need some common functions like mean, sum and all of that. And these functions are not present in the list. So in Pandas, we have something called series, and we can just convert this list into series, which will again be a 1D array only, but with some extra functionalities like mean, sum and all of that. So how I can do that is I will create something called series, and I will do pd.series, and here I can just pass the data over here. So I can just do series and pass data. And now if I try printing the series, let's see how it is going to look like. Now again, to run it, I'm going to press shift enter, and you can see these are the indices and these are the values. Now if I want to put indices also to it, I can just create another 1D list, and I'm going to put A, B, C, D, E into it. And now I can just pass over here that index is equal to index. And now if I print it, you can see the indices are now A, B, C, D, E. But in reality, in real cases, how much will it really happen that the data that we have is present in 1D format? How much are we going to even use series? And that is why we hear about series very less, because usually in reality, the data present is in the form of tables, CSVs, spreadsheets. And that is why the second data structure is extremely important for you, and we are going to be talking about it for the rest of the video. You can think of it like a table with some extra functionalities like, for example, data manipulation, filtering, analyzing, and so on. It is called data frame. It is important to understand that data frame is different from a simple 2D array. See, whenever we read from CSVs or tables, we create a data frame. Now, just think of a CSV or a table or a data frame. Each column can be of different data type, right? Like one column could be of strings, another column could be of integers, another column could be of float. So when you read from the CSV, you're going to create a data frame. So here you can hold heterogeneous data type, meaning the columns can be of different data types. Versus whenever you think of 2D array, what is it? It is of one data type, right? So these two are different things. Your understanding should be completely clear now. We are going to be creating data frames by importing from CSV, but for now, let's get started with creating a simple data frame. So I'm just going to write df equal to, and we can do pd.dataframe. Now here you can see that either I can pass the data or I can just create over here only. So I'm going to be creating a 2D list. Like here I created a 1D list and then passed it. I could have created it separately also. I'm creating it over here itself. So 1, 2, 3. And let's just print it and see. So we are actually done creating our first data frame. Congratulations. And here you can see the row index and the column index. Similarly, just like previously we mentioned index over here, here also we can mention. See, you can see the option of columns. So columns will be like column indexes. So let me just quickly write it down and show to you. So I can give something like C0, C1, C2. And similarly for rows, you can just mention index. So index, these columns and index are like labels for rows and columns. So index is like your label for row. And if I run this, you can see the indices and the column labels are present now. We are now going to look at some example real data sets, and we are going to import from CSV files, Excel files. But there's something you should know about. In mini projects or in YouTube videos, in general, you would see that the file formats that are used are CSV, Excel, and most people assume that this is what is used in data science. But this is used in small projects only. They are not efficient for large data sets. They are just used because they are more universally compatible. They are simple to use. in data science and real companies, when it comes to large data sets, the file formats that are usually used are Parquet files or feather files. So Parquet is PARQUET. So these formats, so Parquet is actually a columnar format only. It is part of Apache ecosystem, Apache Hadoop ecosystem, and feather file format is again binary columnar data. So they are optimized for large data set. Let me give an example. For the same amount of data, if your CSV file takes 1 GB, to store that data set, your Parquet file is going to take only 100 200 MBs and your feather file is going to take only 200 300 MBs. Excel actually takes even more space than your CSV file. It would be like 1.2 1.3 GB because it has more metadata, it has more formats, it has more formatting. But in Parquet and feather, what happens is that there is some compression that is there in place and it is optimized for large data sets. There is something that you should know about, but if you're a beginner, don't worry about it. We are going to be dealing with CSV and Excel. It's just different file formats. Okay, so simple thing, focus on CSV Excel for now. Okay, let's get started with dealing with CSV. So I have taken one example dataset, obesity prediction.csv. You can take any dataset to get started. It's just one example dataset that I have taken. And you can see that I have currently saved it at the same level where my notebook file is for those who don't know. So this is the extension of the notebook file is IPYNB, which is interactive Python notebook file. So I've kept it at the same level for now to keep things simple. And how you can read this is you can do something like obesity data equal to PD dot, and when you try to do read, you can see that there are so many functions available. Read CSV, read Excel. So if you want to read from an Excel file, or if you want to read from a JSON file, or read from a Parquet file, right? Similarly, read from a feather file. So all the options are available. Similarly, so right now I'm doing read CSV. So you can just give the name over here. And also while exporting, so any data that I have, I can also export it to CSV. So I'll also show it to you. So when you try to export to, here there are many options, export to Excel, export to feather. So you can see Pandas makes all of this very easy for us, right? So let's try reading this CSV file, and this is called obesity prediction.csv. Let's try running it. So we have the data present in obesity data. How do we make sure that we have the data correct? So let's just try to print the first 5 rows, and for that there's a function called, so there's something called head. So if I just do this, you will be able to see there are first 5 rows that are printed. How do we know this is the first 5 rows? Let me just show you the data set. So here you can see the first 5 rows. So you can see that, okay, 64, 56, 77, 87, similarly 64, 56, 77, 87. Okay, so these are the first 5 rows. So you must be thinking, Keerti, what if I want to see the last 5 rows? So you can do something like tail, and from the name itself, I guess you might have guessed. So head, tail, right? You can also mention how many rows you want from the top or from the bottom. So if I want to do something like this, I can mention that I want only the 3 rows. So I will get 3 rows, or if I want just the 30 rows, I can do that as well. Similarly for tail also, okay, let me write it separately. So you can check for tail also and mention that I want to see the bottom 15 rows, and you will be able to see the bottom 15 rows. In reality, we will always print like the first 10 rows or the last 10 rows or the first any number of rows just to see whether the data is loaded properly or not, or for some other few reasons. But a more realistic scenario that we would want is to generate some random amount of data. Like for example, I want a sample out of this data that represents the entire data set well. Now, what do I mean by that? See, if I get any random 10 rows instead of the first 10 rows or the last 10 rows, that is going to represent the data better. Why? Because often our data might be like sorted according to a particular column. So if I get just the first 10 rows, the chances are that it is not going to represent the entire data set properly, because, you know, a particular column value might be similar. Maybe it is sorted by weight, or it is sorted by height, or something like that. So we want some random number of rows. We want a sample subset of this entire data. So how can we do that? So I'm just going to do obesity data dot sample. So here you can see I can mention a few things. N is like the number of rows I want, and fraction is like the percentage of the total number of rows. Like for example, if I have 1000, I can mention that I want 10%. So I can just give 0.1 as a fraction, that these are the number of rows that I want. You can also give random state weights. Let me just quickly explain that. So when I write sample, let's first check out the default value. So I'm going to get only 1 row. And instead of this, if I want fixed number of rows, like for example, if we want 10 rows, so I can get this. Now notice that every single time I run this, I am going to get a different output. So here you saw 925 2008. I run it again, different output. I run it again, different output. Correct? Now what if I want to generate random data, but the same data I want to be able to generate again? So what can I do? So over here, I am going to give a state along with it. So when I give, say, random state, I can give literally any integer value over here. Like for example, I give 29 and I run this. Now see, every time I run it again, I'm going to generate the same rows, right? Similarly, if I give another random state, suppose I give random state as 53, okay, any random value. So you can see every time I run this, I'm going to get the same set of rows. Over here also, I'm getting the same set of rows. So I have associated a state to that random rows that I have generated, right? So every time I give random state 29, it is going to generate these rows only. Every time I give random state 53, it is going to generate these rows only. So this is how you can generate a subset of the data to represent your entire data set properly. Sometimes your whole data set is going to be huge and you want to work only with a subset of the data, so you can do this. By the way, if you're using Jupyter Notebook, you can just press over here and go to the full screen mode. I came back over here just to show you that I have saved the CSV over here. But for now, let's come back to the full screen mode. And over here, if you want to just check out the labels like the columns, the indices, you could also do something like this, obesity data dot columns, and if you can just print it like this. If you want to print it in the list form, or you want to see it in the list form or use it in the list form, one thing that you could do is something like this, and this is a list. Or you could also just do a simple to list, and here also you'll get a list only. Other than the columns, you can also see the index, which is like basically the rows. So you'll be able to see the range of the rows. And this is not true just for the data frames that you are obviously getting from the CSV files. Any data frame, okay? So I am explaining you from the big data set from the example, but even these data frames that we made. So if I just create another line over here, and if I want to do something like this, so I can see the columns over here, and I can also see the index over here as well. So I can check out the labels over here also. And so whatever things we are seeing, okay, sample and everything, all of these will work for the smaller data frames also, but I'm just showing you for the bigger data set example. And for index also, of course, you can convert this to list as well. You could also do to list as we did for columns. And if I run this, you can just see it's just indices, right? So, all right. If you want to see the number of rows and the number of columns together, you could also use something like, so here you can use C, right? So it's something called shape. It returns a tuple representing the dimensionality of the data frame. So if I just run this, you will be able to see the number of rows, the number of columns. I can also do something like size, which is going to give me basically number of rows into number of columns, or the number of elements that are there, number of cells that are there. So if I show you again, it is written over here. It returns an integer representing the number of elements in this object, right? So the number of elements in the array or the number of sets. Okay, so you can see like this also. Just notice over here that columns, index, shape, size, all of these are attributes of the data frame. Okay. But now suppose I want to know some more details. Like for example, if I do something like describe. Okay, this is a function. So here when I do dot size, you can see, let me just write it again. So here you can see this is like an attribute, right? Versus over here, if I do describe, it is a function. Okay, so it is going to return me the stats, the common stats that I need. So if I just call this and I show it to you. So let me run this. So here you can see the common stats, like for example, the mean, the standard variation, the minimum, the percentage, right, max, everything you can see over here. Similarly, if you want to see, like here we saw the number of rows, columns. If you want to see some more data or the info of your data frame, you could also do something called info. This is another function, so you will be able to see the info over here, right? So you can see the number of the indices, the columns, the non-null values, how many values are non-null, so the count of that, and the data types, right? So you can see all of that. You can see the range index, that like these are the number of rows, these are number of columns. The number of columns is 17 over here, correct? And all of this again is there for the smaller data frames also. So suppose over here, instead of columns, I want to do, say for example, shape, So I can see shape. Similarly, if I want to do size, I can again do over here size, and you can see 9, right? So 3 into 3 is 9. And similarly, if I want to see, for example, info, I can see info over here. So you can see the number of rows, again R0 to R2, and number of columns, 3 columns. So you can see again over here, and similarly describe. So here again I can see the count, mean, min, and all of that, right? So this is about getting info about your data frame, info, describe, shape, size. Let's get back to talking about accessing data a bit more. So we talked about head, which is accessing rows from the top, tail, which is accessing rows from the bottom, and we talked about sample, like accessing some sample or random rows from the data set. Let's talk about accessing data for a particular row, for a particular column, or group of rows, group of columns. How can we do that? So obesity data.loc. So in simple terms, you can understand LOC stands for location. So here we are trying to access a group of rows and columns by labels. So this is entirely label based indexing. So either by index label, so row label, basically you can think of it like that. So what is the row label? Okay, and what is the column label? So by that we are going to access. So let's see some examples, very simple. So suppose I want to access for the 0th row and I want to access for the age column. So here you can see the columns, right? Suppose we want to access for the age column. So let's try running this. So you can see for the 0th row for age, what is it? And let's see if the data is correct or not. So when I just do head, we should be able to see, correct? And okay, so here you can see for the 0th row, age is 21. Now suppose I want to see for a range of rows, like if I want to see for a slice or for a group of rows, okay, so I am going to do something like this from 0 to 5, okay. So if I run this again, you can see for 0 to 5, or similarly I can run for 0 to 10 as well. So you can see this. Now you can see over here that both 0 and 10 are inclusive. That means when I'm printing this, I am getting for 0th row also and I am getting for 10th row also. So this is inclusive, correct? So this is called slicing, that I have tried to access data for a slice of rows. So here when we saw log, you could see over there it was written, right? Access a group of rows. So this is like slicing of a subset, right? So we are accessing by group of rows. Similarly, I can do for columns also. I can give like a list kind of thing over here. So if I do height, I should be able to get age and height. Similarly, if I want to get age, height and weight, I should be able to do that as well. Let me just run this. So age, height and weight for 0 to 10 rows. Now suppose like here we did 0 to 10, right? So here also we can do like a list. So suppose we want for 0th row, then for 7th row and for 10th row. So we can do that as well. So if I run this, you can see, okay. And range, not only for rows, we can do for column as well. So suppose I want to do for range 0 to 10. And for column, so here we can see age, height, weight, right? So suppose from age to FAF I want, okay? So I can give something like this, age to FAF. So we can see for a range as well. Let's play around with this a bit more because it is very important. This is something that we will do very frequently, accessing data by rows and columns, obviously, right? So let's just copy this. So if I don't mention any columns, okay, then obviously I'm going to get for all the columns. Similarly, what if I don't want to mention rows? Suppose I want for all the rows, but I don't want to mention the rows. So how do we do that? Because the first value that is expected is of rows and the second one is of columns, right? So how do we do that? You can just give a simple column. So for all the rows, I want the values for these columns, age to FAF. So let's do that. You can see for all the rows we are getting the values, right? Similarly, you can give range in other ways as well. Like for example, you want to give from 8th row to say 20th row, right? So you can give that as well. So you can see from 8th to 20th. Suppose you do not want to mention that I want to give from the starting. So if I don't mention any value before column, then it is going to go from the 0th row to the 20th row. Suppose I don't give anything in the end. So suppose I give 2100 and column. So let's try this. And you can see from 2100 till the last one I'm getting. So you can play around with this a bit more, like this is something that we'll need very frequently. So this was label-based indexing. See, labels are just fancy ways of saying names across the axis. Like for rows, the name is index label and column label as the name suggests. What if we want to access data by the integer position, by the index? So let's see how can we do that. So when I do obesity data dot iloc, so here you can see this is integer location based indexing. That was location based indexing. This is iloc, integer location based indexing. It is very simple. There is one very slight important difference over here. Let's see how many of you can notice. So here what I'm going to do is again for 0 to 10 rows, and instead of if I give age, if I give the label over here, I am going to firstly get an error, right? Because it is not expecting your label, it is expecting your index. Similarly, in loc, if I would have given say index, I would have got an error, right? So let me just undo this. So loc expects label and iloc expects your integer based values, right? So indices. So here if I give for 0, let's see. So here you will be able to see that for 0 to 10th row, I am getting the value for the 0th column, right? Here what is the difference? The slight difference is we did not get the value for the 10th row. Let me know in the comments how many of you noticed this. So little things, little differences only. There it was inclusive. Here the upper value is not inclusive. So 10 we did not get, 0 to 9 we got, right? Similarly for the columns also you can give something like this. So here you can get for 0, 1, 2, 3, 4. So here also 5th is not inclusive, right? So this is integer location based. Rest all is very same. Again, you can give for the value, for the specific values instead of the range. You can do something like this also, that I want for say 10th row, 20th row and 30th row. And similarly again I want for suppose 0th column, 1st column, 2nd column, like this. And let's run this. So 10th row, 20th row and like this, right? So now that we have discussed loc and iloc for accessing data, there is one more thing that you should know about. So there are a couple more functions, at and iat. Now, how are they different from loc and iloc? This is for single value access. That is the only difference. See, why do we even need this? Why can't we just use loc, iloc, right? So it is the same thing. Like loc, iloc, we get a group of rows, a group of columns. We can also get single row, single column data, right? But what happens is at iat is optimized for single value access because this is something that is required a lot. What happens is that Pandas is built on top of NumPy in the end. Now, because single value is so common, at and iat is more optimized for that. So there are no extra validations, extra checks that are required. There is a direct reference to NumPy arrays in very simple terms to make you understand. Okay, so let's look at that. So whenever single value access is required, you can use loc, iloc also, but at iat will be more efficient. Simple. Okay, so it is same actually. So when I try to do obesity data dot at, so here in fact it is written, it is similar to loc in that both provide label based lookups. So this is also label based lookup only. So I can just give like 0, age, and I can give like this. And instead of this, suppose I tried giving for a range. Okay, so let's just copy this. And instead of this, suppose I gave at, what is going to happen? Let's see, we are going to get an error. Why? Let's see what is the error. It is saying invalid call for scalar access, right? So because it is expecting single values and you're trying to access like for a slice, so that is not possible, right? And similarly, there is iat. So at is like label based, just like loc, and iat is integer location based, just like iloc. So it's very similar. Obesity data dot iat, and here again it is mentioned it is similar to iloc. Both provide integer based lookups. Only here you need like a single value in the data frame or series. Okay, so obviously all of these can also be used for series. That is why you remember what was series. So revision, if you need revision for everything, it is there in the timeline. Okay, so just check out everything, make sure that you remember everything also, and try writing the code yourself so that you get more confident in it. So series was the 1D array, and this is like we are dealing with the 2D array. You understood the difference between 2D array and data frame, right? So we are dealing with data frames right now. So when I do iat, and if I do, so here we have to give indexes, right? So suppose here if I give I and 0 and age, what should I get? Can you all guess? I'm going to get an error, right? So again, so here you can say invalid call, IAT based indexing can only have integer indexes. So it is actually also telling us, suppose for the index 5, so here you can say I'm getting no. What is no? If you want to see what is no, this is smoke wala no. Okay, suppose we want to see for the 0th column, you will be able to see female. Cool. By the way, for loc and iloc, we had seen that even if we do not give one of the values, suppose I do not give columns over here, I am still going to get the answer, right? But that is not going to happen with at and iat. Suppose, let me actually just show it to you. So if I do this, it is going to give me an error because at and iat expects both values to be there, okay? So that is something to just remember. Also for loc, iloc we saw, okay, let me just show you that if I want to give only the columns and not the rows, I will have to give a empty colon like this, right? Now you might be thinking that is very unfair to columns, right? What if I want to access only for the columns? Then how can we do that? So there are two ways of doing that as well. So I can just give something like this. So you can see age, CAC, I'm getting all the column names over here, right? So what did I do? I just gave a bracket. So if I give a bracket like this, I can just get all the values for that particular column. So this is for a particular column because loc, iloc majorly focus on rows. So when you want to access for a direct column, it is like a dictionary, right? Simple, in very simple terms. So you can just access like this. And this is called bracket notation. You can also do it using dot location. So if I do this, you should be able to see. But there's going to be a problem with dot location. There are multiple problems, but one very major problem. Can you all think of something? So here, I don't think in this example, we have an example like that. So suppose in family history, like there was suppose a space, right, between family history instead of being an underscore. Then when you would give obesity data dot family space history, it would not be able to read, right? So there are cases when your column names have spaces and all of that, that would be problematic. So what is usually suggested is that you use the bracket notation instead of the dot notation. So that is more flexible. So any columns that you want to access, you can access like this. Also, if you want to access for like multiple columns, you can just do this. So suppose height, and we do this, we are getting an error. Why? Because we have to put this inside another list. Very good. So if we do this, here you can see. Similarly, here I can give another, right? So this is how you can access for multiple columns as well. So far we have seen how to access data by rows, by columns, single row, single column, single value and all of that. But what if I want to run some interesting queries or some interesting filters over my data? For example, what if I want the data for only those folks who have a family history or who don't have a family history, or who have a family history and who smoke, who have a family history and they don't smoke, or for folks who have height greater than this, or for folks who have height greater than this and weight greater than this, or height less than this or weight less than this. So you get the point that what if I want to query based on some conditions, maybe multiple conditions. What if I want to filter my data and get my data based on some conditions? That is the whole point. Now think about it logically. Out of loc, iloc, at and iat that we have discussed, what do you think we can use over here? See, at and iat is for single value access, so that doesn't make sense over here, right? I hope I don't have to explain you why, because most of these conditions are going to generate multiple rows and columns, so it's going to be multiple output, and at and iat gives a single value output, right? So it doesn't make sense. Out of loc and iloc, what do you think makes more sense over here? Obviously loc, right? Because loc is what? It is label based indexing, and our conditions are going to be based on labels, like age greater than this or weight less than this or something like that, right? So it is based on labels. So it makes sense to have label based indexing instead of position based indexing. So I just wanted you to understand that why loc is used for all this querying and filtering. The main reason behind it is that, see, loc supports Boolean based indexing and the other three don't. Now what is Boolean based indexing? When you have these conditions, right, that this greater than this less than whatever, these conditions are going to generate a Boolean value, or true or a false. So loc supports Boolean based indexing, meaning based on this Boolean value, it is going to generate data for you. It is going to generate that, okay, these rows and columns are true for this particular condition that you have given, or it's false for this particular condition, right? So I hope that makes sense. Let's look at some examples. Let's get started with seeing that what all columns we have. So I'm just going to print the head and I'm going to see the first 20 rows so that, okay, we have the columns now. So we have gender, age, height, weight, family history, we have smoke. So let's get started. I'm going to do obesity data.loc and let's see some conditions. So we have height and I think this is in meters. So we can do something like where the height is, say, greater than 1 meter. So let's just run this, and so we have all the rows where height is greater than 1 meter. Similarly, we can have more conditions. By the way, here you must have noticed that we are getting the data for all numbers like age, height, weight up to 6 decimal places because by default it is using float. So earlier it was not the case. Now it happened because we put the condition like that. By default it is taking in float, but we can obviously round it off to 1 or 2 decimal places. Not going to be talking about that because that is not the main criteria or what we are focusing at, right? So let's just go ahead with more conditions. Suppose weight less than 50. Let's just see all the folks who have weight less than 50. Now let's try adding multiple conditions. So when weight is less than 50 and suppose for example obesity type, okay, so we can have probably obesity data and the obesity type or the category is suppose equal to normal weight. So when you have weight less than 50, how many of you are in the normal weight criteria? Now when we give multiple conditions, remember we have to put brackets in both the conditions, otherwise it is going to give you an error. So let me actually show it to you. So you can see that there is an error, and above exception was direct cause of the following exception. And let's see, where is the error written? Unsupported operand. Okay, so let's just quickly add the brackets. So I just wanted to show it to you so that you remember to not make these mistakes. Even if you do, it's fine. You'll learn, right? So let's try running this. And this is how you can run multiple conditions. We can, like right now we had and, right? We can also have or. So where obesity weight is less than 50, like weight is less than 50, or the obesity category is equal to normal weight. So let's see. Over here you can see that weight is greater than 50 also for some rows, and for some rows it is in insufficient weight also. So right, so either of the condition is true, we are getting all of those rows. Here both conditions had to be true. So it is always less than 50 and always normal weight. I hope you understand how and or works. I'm not going to be explaining that. Now comes the interesting part. The interesting thing is that you actually do not need to use loc. They must be thinking, Keerti, this is betrayal. Why have we been talking about loc? See, when we do so many filtering and querying, in Pandas, we have shorthand notation for Boolean indexing. By the way, I was using the term Boolean-based indexing, I realized, but you can just call it Boolean indexing. In the documents also, it is just called Boolean indexing, Boolean-based indexing, same thing, right? So if I don't write loc also, it's the same thing. So when I write this, I can just remove loc. So this is called the shorthand notation, okay? And you can see we are going to get the same output. This is like using map, right? Like in map, you're just giving conditions. But I wanted you to understand that you can use loc like this also, and why loc, right? So both ways of writing code. So many ways of achieving filtering, querying, and I hope this seems interesting to you because like this is very common use case, right? Very often you will need data with particular conditions. You will need to filter out data. So that is why a shorthand notation is also very, very important. Make sure you practice this out. Also, since we are talking about querying and filtering, we have to talk about regular expressions. See, regular expressions are extremely powerful. There is so much that can be done with it. In general, in regular expressions, whatever, if you know about them, or I can make a completely separate video just on regular expressions, let me know if you need that. Let me know in the comments. But let me give you a very simple example. Over here, I think in our data, we have very less number of strings, but I can still show you. So we have like a couple of columns. So let's look at that. Let me use loc only for now. So I can do something like obesity data of, suppose we talk about obesity category, and we talk about the string version of this, and then we see these are the things that we can see. We can see, does it contain a subword, a substring? We can decode, encode, we can check, does it end with this? Does it start with something? So there are so many things we can do. We can full match, find all, is digit, right? So there is so much that can be done with regex. It's extremely powerful plus multiple conditions, right? So I'm just giving a very simple example. So we can check, suppose contains. So does it contain, for example, normal? Okay, let's just check and let's run this condition and let's see, is it going to work? Yep. So we can see all the rows where the obesity weight is normal. Now instead of this, suppose I did something like starts with. So this will also work, correct? So it starts with normal only. But what if I want to see rows that starts with weight? Okay, so let's just check that. So there are literally no rows, right? Because they all start with insufficient weight, normal weight, and so on. So you can see there are no rows that start with the substring weight. So like this you can do, and obviously all the regex expressions you can do without using loc also. So all the conditions regex you can do without loc, just like a simple Boolean indexing you can do over here. And similarly for here also, let me just show it to you. So you can just remove .loc and you can run it and it will work. Nice. So far out of the CRUD operations, we have discussed creation of data frames, we have discussed reads or accessing the data from the data frames in a lot of detail, and now it's time to start talking about the updates or the modifications. So the good news over here is that loc, iloc, @, and the shorthand notation, all 5 work for modifications as well. So just like we were accessing the data, the same loc, iloc, and @, can be used for updates and modifications. So it should be very easy for you. Don't worry at all. Let's just quickly look at the examples. Let's get started with loc. So let's just do loc. Loc is label based indexing. So your modifications are also going to be label based. So I'm just going to mention age over here. Maybe let's try to update for the 0th row. Age earlier was 21. Let's try to make it maybe 22. And if I run this, so it should have been updated. Let's check it out. So if I just print the head again, so we can see that the age is now 22. One thing to note over here is that all the modifications that we are going to make are going to happen in the original data frame itself. So just keep that in mind. Loc again can be used either for single values or for like an entire row, entire column, or for a slice of rows, slice of sub columns. So let's give that a shot. Let's just look at more examples. So instead of just for a specific value 0 age, let's try that maybe all the users whose data we have, none of them are smoking. Suppose I want to update smoke, let's say all of them are smoking. So let's update this to yes, because a lot of them are no. So in the head itself we can see a lot of them are no. So let's update all of them as yes, right? So for all rows, if I want to update smoke, right, and I am going to update that as yes. So let's run this and now let's see the head. Now you must be thinking, let me run this. Yes, so it is changed to yes, right? And instead of just the top 5, suppose you want to see more rows to be absolutely sure. Maybe if you want to see tail, let's run that as well. So you can see here also it is yes. Now you must be thinking that Keerti, you changed the original data frame and we are just playing around with it. What if I want to get back to our original data? You can just read the CSV again. This is if you are, playing around with it, you can just read it again. Let me come back over here. So let's just read this again. And now if I get the head, you will be able to see that it is all no, yes, no, yes. And if I update this again, so this is like a cool way of just, trying things out. So yep, let me run this again. So now if I get the head, it is all yes, correct? So this is again all yes. Let's try for range of rows or range of columns also. It will work similar to how access was working. Same thing, it will work over here also. Let's just take a couple of more examples. So here we can see that suppose the age over here is 23, 27, height is 1.8, 1.8. So maybe let's try updating the height of both of these people to say 1.6. Suppose that is what we want to do. So I can probably give a list. So for 2, 3, if I want to update height to say 1.6, and if I check out the head again, I should be able to see it as 1.6. Now instead of this, suppose I gave like a range. So suppose from starting till second one, update the for example smoke parameter to say no. So for these 0, 1, 2, so this should become no essentially, or let's give yes. So all three of them should become yes, right? And suppose we want something else, maybe. Okay, let's try giving that as well. And if I again check head, and I should be able to see my changes. See, maybe, correct? So this is how you can play around with loc. Let's quickly look at iloc also. How is it different from loc? Loc is label based, iloc is integer position based. So the only difference is that now we have to mention the integer positions. So let's quickly write it down. Iloc, and suppose over here, what example should we take? Suppose for family history, so for rows 1 to 2, or just for the row 1. So suppose for the row 1, I want to update family history to be no. So family history is 0, 1, 2, 3, 4, correct? So for 4, I should be putting no. Okay, let's try running this, and let's look at the head. And you can see that this has become now no, correct? If you want to be absolutely sure and put this completely something else, something like no data, and let me run this so you can see here no data, correct? Again, you can do this for a range of values as well. So suppose I want to update the smoke to be yes. So for all the rows, I want my smoke to be something like doesn't matter. Okay, I know it's just random info that I am adding. And okay, I have given smoke. Why is it giving error? You tell me. Because we are using iloc, so it is expecting an integer value, right? So we have to give integer position 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9, correct? And let's quickly run this, and let's look at the head again for maybe the top 20 rows, and here you can see it is doesn't matter. So iloc also we have seen. Let's look at and iat quickly. At is for simple single values. So if I give suppose for the second row we want to update that the obesity level is suppose overweight. Okay, so for this second guy, so let's say second guy, so right? So should I give the integer value, or should I give the label? So I should be giving label because I'm using not iat. So let's give obesity, and let's just write this as over. Okay, I'm just playing around, guys, and let's just okay, let's look at the head, and you can see that this is over, right? And let's look at iat as well. So when we look at iat, let's update suppose the gender. Suppose someone wants to update their gender, and in the 0th column, let's update the gender to secret. Don't want to reveal. Okay, and let's look at this, and let's look at the head again, and you can see it is secret. So this is how you can play around with it. You can use all 4 for modifications as well. For the shorthand notation, if you remember, while we were discussing accessing, we had discussed that when we want to access data for a particular column, we can use shorthand notation. It's like a map, if you remember that. If not, just revise through the video again. Similarly, over here, when you want to update an entire column, like for example, I don't know why smoke is my favorite column today. Here, if I want to update, so this was doesn't matter. Let's update yes for all the folks. Let's update the entire column, and if I check out the data again, if we check the head, we should be able to see it is yes for all. Similarly for tail also, like for any data essentially, it is all yes, correct? In all the updates and modifications that we have seen so far, we already knew the new value. What if I want to apply some kind of transformation or function across an entire column or across an entire row? For example, suppose over here, hypothetically, I have age, height, weight. Now, what if I want to increase age of all the data points by 5? Just one possible case. Maybe the data was from 5 years ago, or maybe there was some mistake in the calculation, something. I can also do very complex kind of transformations also. Very simple examples would be multiply by 2, divide by 2 and all of that. Maybe I want to add another column calculating BMI based on height, weight and all of this. So all of these kind of transformations are also possible. We will see how to add new columns, but for now, maybe what if I just want to increase my age by 5? So how can we do that? See, now I want to apply a transformation. So Pandas has something called apply, so that you can apply these transformations. So let's actually use that. I just want you to remember these things, and that is why I speak like this: apply the transformation or apply the function, right? So right now we are going to be applying it on the age, and when I do dot apply, see here you can see that it expects a function, and there's something called access also. So by default, access value is 0, which means that whatever function we are going to be passing is going to be expected to work on a column. You can also do access equal to 1, but column is the more common, better fit over here, right? It makes more sense. So let's do it across the column, and we are going to be applying, and I need to pass a function over here. So let's just write increment age by 5. Okay, so this is a function that I am going to be writing, and let's quickly define this. So def this, and I'm going to be passing some age value, so x, and I'm going to be returning x plus 5. So this is our function, we have already given this. So just to see that, okay, the change has happened, we can either print head, or let me just print just the age value, and let's see if actually the change happened or not. Now let's try running this. Here we can see that the change did not happen. If I see for the first 5 values, 21, 21, 23, 27, 22, did not work. So am I teaching you wrong? No. See, by default, apply does not change your original data frame. These are the little things that you need to understand. As you practice, you will just get the hang of it. So what we can do is, whatever are the changes, you can just put it in your data set, in your original data set. You can do equal to, so let me actually show it to you. So over here, if I assign the value now of the applied, whatever is the applied value of the transformation, I'm assigning it to the age column. Now you should be able to see the change, right? And if I want to go back to the original value, I can just do -5, and I can go back to the original value. So you can play around like this, right? So I'm just changing it back to +5 for now. And you can apply transformations like this across columns, across rows. If we look at this example here, just to add 5 to one value, we had to write a separate function. Now, when the transformations are so simple, there are easier ways as well. See, if the transformation is very complex, suppose a lot of calculations are required based on some conditions, there are many checks, then it makes sense that we have to, have a different function, we have to define a function. But if the change is very basic, if the transformation is very basic, as simple as this, there should be a better way. And yes, that is there in Pandas. So let me show it to you. So in apply, instead of defining a new function, you can use something called Lambda. You must have heard of it. It's there in other programming languages also, C++, Java, C# and all. Let me know if you have ever heard of Lambdas. It's very simple. It's just a fancy term. It basically means that instead of having to write a separate function defining it, I'm going to write a small unnamed anonymous function. So this is like, instead of creating a separate function, I'm going to give over here only what I have to return. So what I'm going to do is, I'm going to write over here lambda x, whatever is the value of x, and what am I going to return? So I'm going to be returning x minus 5. Let's go back to our original value, and let's print it out. So to see that, okay, the change happened, and let's run this. Here we can see that the values are back to -5. So very simple, right? Let's quickly look at one more example. So here, if we see in our rows, in our columns, we don't have something called age category. So maybe let's add a new column itself, that if the age, I think it is in the range of less than 30 only. So maybe for 21 to 25 people or less than 25 people, we are going to call them young. Otherwise, we're going to call them old. Yes, I am old because the data is like that. It's fine. So let's try applying it. See, there are many ways of adding new column. Okay, there is something called insert as well, but very easy way. Let me tell you the easiest way. What you could do is simply write the new column that you want to add. Okay, age category, and what we are going to do is, we are going to do apply only. So we are going to apply it on the age itself, and we are going to use lambda. Okay, so let's use lambda. Whatever is the value of x, I'm going to assign very young if x value is, say, less than 25. Else I am going to say that you are not so young, you are mature. Okay, and let's try running this, and yep. And if we see the head now, or let's see the first 20 rows, here you should be able to see something called age category. So yep, so we can see all of these folks are very young. Is there anyone who is not so young? No, the age for everyone is less than 25. This guy should be not so young. Let's check. Not so young. Yep. So rest are very young. This is not so young. Here also there is not so young, because there are ages are 25. Okay, so this guy 24, very young. Okay, not so young, 25. Yep. When we are doing something as simple as this, there is one more way. Don't get overwhelmed. See, if you are new to this, knowing just apply is good enough. I'm just telling that there is one more efficient way. You will get the hang of it as you practice more, as you write more. You can go through the documentation. This video should be a good reference for you that all of this can be done. Okay, so if you're getting too overwhelmed, it is okay. Don't worry about it. I'm just going to tell you more efficient way as well. See, Pandas again built on top of NumPy. So here when we have to do something as simple as this and we have to apply it across the entire column, it's not like we want to do it across a row, across a particular column, across a particular row or for a particular value. The function is not very complex. It's a very simple transformation. We can use directly NumPy ka vectorized operation. Now let me actually show it to you how that works. We are just going to import NumPy as NP. By the way, how many of you would be interested in a NumPy dedicated video, like how this is Pandas in one video? We could also do NumPy in one video. Let me know how many of you would be interested, and we can definitely cover that as well. So what we can do is, if obesity data, let's create yet another column, and we are going to call it, suppose, new age category. And what we are going to do is, inside this, we are going to do np.where, and we are going to pass obesity data. Okay, and for the age only, we are going to check that if this value is, say, less than 25, then we are going to put very young. Otherwise, we are going to put not so young. So this syntax is slightly different than what you must have seen. Like here, it's just separated by commas, but you get used to it, right? So, and let's just run this and let's see the head. And here you should be able to see new category, which is same. So if you want to see the first 20 rows, instead you can see that all the values are same, not so young and very young. Coming back to adding new columns, we discussed that we can add new columns like this very simply. If we want to add a column at a particular position, maybe like at second position, first position or something like that, we could use insert also. It is very simple. So let's just look at that as well very easily. So here we can see that in insert, it expects location, column, value, and if we want to allow duplicates or not. So 4 values it is expecting. First is location. So suppose we want to insert at the second location. Then this next thing that is expected is column name. So suppose the column is BMI. And the next thing that is expected is value. For now, suppose we want to say that BMI of all our data points is basically 20. So let's actually run this and let's look at the head, or let's look at the first 20 rows and let's run this. And here we can see that BMI 20 is there. If we want to delete a particular row, let me just show that as well. So suppose you have made some mistake and you want to delete a particular row, you could also do drop, and over here you could give columns. So if you see in drop itself, I think it would be mentioned, right? So here you can see access, you can give which all columns you want to drop and all of that. So if I just give columns, you can give a list also, or you can just give like this. Suppose I want to drop multiple columns, I can drop like this, and that's it. If I do this and I print again, let me actually show it to you. So if you do this, so BMI is not there. But now interestingly, let me show you something. If I see the head again, you will see that BMI is still there, right? So this is again one interesting point, that drop does not actually change the original data frame. So you have to explicitly mention, again, there are 2 ways to do that. Either you can do it in place. That means that you could do this. So you could do something like this, in place equal to true. So if you see in the drop function itself, everything is mentioned. So if I try writing this, you can see it is mentioned over here, right? So if I do true, then it will change in the original data frame. So here you can see there is no BMI now. Suppose I add BMI again, and let's do that again actually. So if I insert, and this time instead of adding like 20 for all of them, let's do some calculation also. Suppose I'm inserting at second location, the column name is say BMI, and let's do some calculation. So over here we can do some basic calculation. Suppose weight by height square is BMI, right? So weight, right, correct, let me actually just copy paste, weight divided by height square. So obesity data of height and square, so 2 into 2, and let's just run this, and I think this should work. And if I print the head again, you should be able to see that there is BMI, correct? And if we want to drop, instead of doing in place true, see again, let me show it to you. If I don't do this, it will show me the updated data frame. So there is no BMI over here. But if I look at the head again, you will be able to see BMI. So if you want to update over there itself, either you can do in place true, or you can again just assign. So obesity data equal to obesity data dot drop. So now if I run this and I check out the head again, you will be able to see that there is no BMI. So what are things we just covered? You can do insert. So in insert, there is location, column, and then the scalar value. So you can do that, and then you can see that, okay, the value is added. If you want to drop a column, just to drop columns, you could also drop multiple columns. Suppose, let me actually show it to you. If I am inserting, let me insert a couple of columns. So if I, instead of BMI, let me BMI new. If I insert another one, okay, and if we print the head, you will be able to see that there is BMI new. Okay, let's add this as well as the BMI one. So let me actually add both of them so that we can drop them together as well. So now if I look at the head, you will be able to see there is BMI and BMI new. So if I want to drop them together, I can do dot drop, and I can do columns equal to, and I can give a list. So list is like BMI and BMI new, correct? And here let's do in place equal to true. So if I do this and I run this, and if I check out the head again, you will be able to see that BMI new, both are not there. But if you tell me that, Keerti, we don't want to do all of this, we don't want to do in place equal to true, we don't want to assign and all of this, you could simply do delete as well. And that is the same thing that is used like the Python keyword. So you could just do delete and obesity data. Suppose we want to delete the 𝐶𝐴EC, and let's try deleting this, and let's see. So it will not return us something because it is not like it generated a new data frame. It made the change in the original data frame only. So if I actually check out the head, you will be able to see that there is no 𝐶𝐴EC column now, right? So you can do that. Also, if you want to rename a particular column, you could do that as well. Basic stuff that you want to play around with it, you can do that as well. So if I just go to rename, here you can see we have to give columns, and there is also option for in place. So you can also firstly rename multiple columns. Secondly, in place meaning ki by default it is false. So if I do not give in place equal to true, it is not going to change in the original data frame. Either you can do in place equal to true, or yes, you guessed it right, or we can just assign the assign to the original data frame. So I'm going to give rename and columns. So first let's try for one column. Suppose for obesity, let's say for obesity, we are going to change it to, say, for example, category. So let's do this, and if I run this, here you will be able to see that category. All right, but again, if I just check out the head, no change over here, it is still obesity. And if I give this as in place equal to true, and if I run this, and now if I check the head, you can see that this has now become category. You can also replace multiple columns, like rename multiple columns. So suppose instead of new age category, let's give, okay, so instead of this, suppose we are going to give redundant info. we are going to also remove this, so it should be fine. And if we run this, you will be able to see that this is now redundant info and it is in place. So let's try deleting that quickly. So obesity data and redundant info, if we do this, and if we check out the head again, you should be able to see no redundant info and category. Let's get to some more interesting stuff now. Just like in SQL, we can perform joins. Here also we can combine multiple data frames, or we can merge multiple data frames based on one or more common columns. This also supports inner, outer, left, right joins. So let's see how we can do that. Big data would be a bit harder to understand, and we would obviously need multiple data frames for me to be able to show it properly. So let me just create some like two very simple data frames, and then we can see how joins work on these. Let's get started with creating our two basic data frames. So I'm just going to call them df1, df2, pd.dataframe, and I'm going to create basic ones only. I'm just going to give like ID and name. So let's do that. I'm going to mention some random IDs. Let's give a list 1, 2, 3, 4, and probably some names. Let's quickly add them. Similarly, let's add the second data frame also. So I'm just going to copy. Our ID can be our common column. So instead of giving all the values as common, I'm just going to give a couple of common values. So 3, 4, 5, 6. And instead of name, let's probably have course. And we can have different courses over here. And now we are ready to perform our joins, or we are ready to merge on these data frames. So we are going to be merging these data frames. So let me just store the result in different variables. I'm going to probably start from inner result, and we are going to do pd.merge. Now if we see merge, there are 4 values that we have to pass. You can see over here. First is the left data frame. Then there is right data frame. Then how do we want to merge? So do we want to do inner, outer, left, right? We will see all 4. And on what? So you have to mention the index label. The column that is common, that label we have to mention. Okay, so let's pass all of this. So our left data frame is going to be df1, right is going to be df2, and we are probably first going to get started from how. So we are going to pass inner, and on is going to be our ID. So I think we are ready to perform our first merge, and let's just write this down. So you can see the common IDs are going to come, because inner is like intersection. So suppose I did not have 3, 4 and I had suppose 5, 6, 7, 8. Let's try that. So if I had 5, 6, 7, 8 and if I ran this, you would see no output, right? Because there are no common column, like there are no common IDs over here. So now if I go back to my original values, 3, 4, 5, 6, if all of them were common, again you would be able to see that we would get the entire output, correct? So let me run this also. You can see all 1, 2, 3, 4. So now let's go back and let's run this again. So now let's perform different kinds of joins. So if I do suppose outer result, and let's save it over here, and I want to do outer and on ID only. If I run this, we can see we are getting all of them, and you can see a lot of NaNs. NaN stands for not a number, but don't get confused. It is for any missing or undefined value. It just doesn't have to be just numbers, any string, anything. Any value that is missing or undefined, you will see NaN over here. Okay. So you can see that over here, even though course values were not present for this ID, over here names were not present for this ID, you will see all of them. That is the outer join. This is like union, right? So this is like intersection. Inner is like intersection. This is like union. Let's see left and right as well. So let's just quickly check it out. If I do left result and I quickly print this, we will be able to see that we are getting all the, let me just run, okay, we have done outer only. That's what I was wondering what. So now let me run this. You will see that all the left values are there. So even if right as null, that is fine. But left null you will not see. You will see right as null. But these two IDs you will not see, because here left value is null. Similarly, if I do right null, if I if I do write merge, or if I do write join. So let me do write over here and let me run this. So you can see left values can be null. So you will get for all of those values where right value is not null. So all the IDs that were there in the right data frame meaning the second data frame. So we'll get for the IDs 3, 4, 5, 6. You will not get for the ID 1 and 2. Right now in this example, what happened was that the common column that we had the same label in both the data frames. The label was ID. But that might not be the scenario in real cases, right? Because in real scenarios, in one data frame, it might be like in one data set or CSV that you have, it might be called say user ID. And in another CSV or in the other data frame, it might be student ID or employee ID, correct? So same common column only, but different labels in both the data frames. So how do you handle that? So let me actually copy this and let me show it to you how you could do that. So if I take this as a df3, df4, now the common column is going to be still same, but they are with the different names. So this is suppose ID1 and this is suppose ID2. It can be anything. I'm just showing you an example. So here again we are performing the merge on df3, df4 only. And we are performing in and merge only. The only thing is that now we do not have this common label. So what do we do? See, in times like this, you can actually just check out the documentation. So just whenever you are about to write the merge function, you will be able to see over there that there is something called left on and right on, right? So you can learn like this as well. So instead of giving on, what we are going to give now is left on, and I'm going to give ID1. And similarly, we are going to have right on, and I'm going to give ID2. Now let's try running this, and we can see it still performs all the joins. It is going to work like this. So you can try like this for inner, outer, left, right. It is going to work in the same way. Let me just show it to you. And yes, you can see that, right? So I'm going to be writing only for one, but I hope you have understood. Sometimes what might happen is that we want to combine our data frames like how we have been doing so far, but not on the basis of some common column. Maybe we just want to stack them on top of each other, or we want to concatenate them on top of each other. Now that can be row wise or that can be column wise. Basically stack them either vertically or horizontally, right? So this is called concatenating two data frames. So this is just different way of combining the two data frames. We can check that out also. So let me just copy this again and let's do this. So suppose these two data frames, we are going to concatenate them. So we are just going to store the answer in this result. And instead of merge, what we are going to be doing now is concat. So here you can see we have to give the iterable either series or data frame. Basically, what all data frames do we want to combine, or what all data frames do we want to concatenate. So we'll give that, and we will give axis. Axis meaning either we want to do it vertically or we want to do it horizontally. So let's look at that. Suppose, okay, let's get started. So I'll give the iterable. So it will be df1 and df2, and let's mention axis equal to suppose 0, and let's run this. And you can see that these two data frames are stacked on top of each other. They are vertically, right? And here you can see that this ID was 1, 2, 3, 4, and now there is 3, 4, 5, 6, right? So this ID was same only because it was same in both, right? Now it has created its own 0, 1, 2, 3, 0, 1, 2, 3. Now this 0, 1, 2, 3, 0, 1, 2, 3, but the actual ID should be 0, 1, 2, 3, so on, right? Like 4, 5, 6, 7, 8. So for that, what you could give is ignore index equal to true. So if you ignore the index, now you can see it will come from 0 to 7 instead of being repeated. Let me show it to you again. So if I remove that and I run it, you can see that ignore index was false. So the index remains same. But if I do this, you will be able to see that I am able to see the new indices. So now this was vertically. If I want to see suppose horizontally concatenation, then result 2, and I am going to give axis equal to 1. Let's just remove this for now and let's run this. You can see it is stacked horizontally together, right? So this is concatenated horizontally. You can also mention keys. So when we do this, if I mention keys over here, and let me do on the axis 0. So when I give keys, suppose I'm going to mention both the data frames over here. So df1, df2, and if I do this and I run this again, you'll be able to see that hierarchical indexing is created or multi-level indexing is created, so that you can differentiate the rows that are coming from both the data frames. So these rows are coming from this data frame, these rows are coming from this data frame. So this is multi-level indexing. I know you must be thinking that, Keerti, while combining these data frames or while doing our merge and concat, we saw so many null values, the missing, undefined, NaN values. How do we handle them? Because these obviously don't seem to be good for real scenarios. In real cases, these are going to have some repercussions or consequences. And you're absolutely right. Let's take a very simple use case. If you're trying to find average of all the values in a column and a lot of values over there are null, then does average even make sense? When a lot of values are null, then average doesn't make sense, right? Similarly, when you feed your data into machine learning models, if a lot of values are null, then not only is performance impacted, in fact, you might even get errors. So firstly, we should not be able to just detect the null values. We should also be able to handle them properly. Now, there are various ways to handle these null values. Firstly, let's talk about how can we detect the null values, and then we will talk about how to handle the null value. Suppose let's get started from this result 3 itself. Now here itself, if I want to see is NA. So okay, let's see what is written over here. In the function, you can see key detect missing values, return a boolean same size object indicating if the values are NA. So what we are going to do is, if we run this, see, same sized object. So whatever was the size of this data frame, we are getting the same size object and we are getting false or true. So wherever the values were null, we are getting true, right? Similarly, we could also do not any. So if I do not any, you can see detect existing non-missing values. Again, it will return a boolean same size object indicating if the values are not null. So let's run this. You could also see the sum, okay, like how many values are null, how many are not null. So if I try doing sum, and let's run this. Here you can see how many nulls are there in name, in course, right? So over here, if we see in name, how many nulls were there? 1, 2, 3, 4. In course, how many were there? 1, 2, 3, 4. So this is for detecting, right? Similarly, we can see in non-null also. Suppose we want to see our data frame is going to be huge in real scenarios, right? In obesity data, if we want to see, I think there would be no null data because that I downloaded online. So yeah, there is no null data over there. But suppose over here we want to see that not any, what is the sum, how many non-null values are there. So again, we'll be able to see how many null values, not null values are there. Once we have detected the null values, now we have to handle them. There are many ways of handling them. One way is to fill that null value with some value. Now let's see how we can do that. Let's come back to our obesity data. We saw that there are no null values over here. So how can we firstly to play around, put some null values inside this, right? So let's do that. We can use loc for that, right? So that's why we have learned all of this. So let's put for the 0th row, suppose age. Okay, so if I put this as np.nan, that means it's a null value. Now if I print the head again, let's see, we can see that there is null value over here. Similarly, let me put null values in 2, 3 more places. Suppose let's put in 0 for the smoke, and suppose let's put for the, suppose second row, let's put for the family history. All right, so let's do this. And now when I see head, we can see a bunch of null values. So over here, and over here. Now what can we do? One way that we could handle this is to fill the values with something. So obesity data dot fill any, you can say, right? So with what value do we want to fill? We can give that, and then there are some methods, there is access and all of that. And there is in place also. So what does that mean? By default, it is false. So it was not going to make change in the original data frame. Let's check it out. So suppose I say that fill the values with 0. So that means that wherever there is NaN, like wherever the value is null, just fill all of those values with 0. So if I see this, see over here, in smoke also I have put 0, and in age also I have put 0, and in family history also I have put 0, right? But it doesn't make sense over here. Right now what I have done is that wherever you find null data, just put 0. And if I see the head again, let's just see that. So if I see this again, we can see that the values are still NaN. So the change actually did not happen also. So the first thing that we have to do is put it in place, right? So in place equal to true, and if I run this, now if I see the head, you should be able to see that all the null values are now changed to 0. But that does not make sense. So how can we handle this better? Now there are multiple ways of handling this, but before we do that, let me actually copy the null values so that we can see the null values and then we can play around with it. And let me just print the head as well, and let me run this. So here we can see we are back with the null values. Now when we do fill NA, instead of filling all the columns, what we could do is actually mention that we want to fill only for these columns. And there are many ways of writing that as well. So suppose I want to fill only for age, right? So here there is NAM. I don't want to fill for this column or for this column. I want to fill only for age. And what I want to do is fill NA, that wherever in age the value is null, you just assign it to 20. Now I could also do it like so that it reflects in the original data frame. I'm just going to put it like this, and let's run this. And now if I see the head, we should be able to see that this has now become 20. Not just with 20, what we could also do is we could find a mean of this. So I will have to again assign it to null to be able to do that. And what I could do is for age, just find the mean of that value, and we are going to be assigning to that. And now let me run this. And now if I do this, you will be able to see that age is assigned to the main value. So here you could see that once I ran this, it was null. And after this, so whatever was the mean of all the ages that we had, we assigned that. And this makes so much sense, right? That whatever is the mean value you get, just put it to that. And while filling these values for a particular column, it is not necessary that you have to do for one column only. You could also do for multiple columns together. For example, we could do something like this, fill NA, and over here we could mention that, for example, for smoke, if the data is not present, like if it is missing, you just assign it to no. And similarly for say family history, if the value is not there, then just put it to no. Or you could put something else, like for example, maybe, or something like that, whatever you want, right? So let's try running this, and let's look at the head again. By the way, again, this wouldn't be in place, and I could do in place equal to true, and let's run this, and let's look at the head. And once we do this, you will be able to see that over here for smoke there was NAN, and now it is no. And for family history, over here it was NAN, and now it is again no. So this is how you could do for multiple columns as well. There is so much that you can play around with this. Let me actually give you more examples. So if I put the null values again back, and now instead of putting the mean values, what you could also do is, instead of mean, you could like give more things like interpolate. That means based on some patterns in the neighbors and all, it is going to fill the values. And if we see this again, you'll be able to see that age right now is NAN because it was the 0th row, versus if it was in say any other row. For example, suppose this was in the 3rd row, and if I run this again, and now if I do this, I think it will be able to fill this. So right now if we see in the 3rd row it was NAN, and now it was able to fill it because here it did not have the earlier one, right? So here it saw from the neighbors, and based on from the neighbors it took the value. So here it was 18, here it was 17. So it took the mean of just the immediate neighbor, 17.5. There are many ways of this. You could also use interpolate directly. Like for example, you could do something like this, interpolate. So here also you could use this function directly instead of using fill NA. Now this also you can mention limit, access, in place. So there are a lot of things that you can play around with, like even with filling. So when I do fill NA, now over here, suppose I'm filling anything, right? Okay, I'm filling with 0. We could also mention limit. Limit meaning ki in that particular column, suppose I am filling only for age or only for smoke, anything. Okay. So I am filling for that particular column. That means that in that column, how many are the maximum number of null values that I want to be replaced. It's not like if all the values are null, then I want all of them to become 0. Maximum these many values, if they are null, then I want them to be replaced by 0 or something like this, right? So you can play around with this, and if you have any questions, just let me know. Another thing that you could possibly do is decide that you do not want to fill the values and you just want to delete or drop all the rows or all the columns where any of the values are null, or any specific row or any specific column. So let's look at that also. You could use something called dropna. By default here the axis is 0, which means it is going to delete all the rows, and by default it is in place equal to false. If I give in place equal to true, it is going to be irreplaceable. So what I'm going to do is I'm going to drop all the values that are null. So let's actually see over here once more. So when you run this, you can see that these values are null, right? So this and this are null. So if I just do drop na, you will be able to see that there are no null values now. But if I do obesity data.head, you should still be able to see the null values because it was not in place. So now if I do in place equal to true and I run this and I look at the head now, so you can see that there is no 2 over here, right? Because that entire row is gone. There is no 0 as well. There is no 0, there is no 0, there is no 2 because those rows are gone. There the values were null. Similarly, over here, when you drop and you give axis equal to 1, you will be dropping the columns. There are a lot of conditions that you could actually also add. For example, you could have something like keep for only this particular row or maximum these many number of rows that I want to delete. Okay, if this is the number of the null values, then maximum these number of rows just start deleting from the top or from the bottom. So there are a bunch of things that you could do, but just showing you how you could do it, like drop na. So here's the documentation. You could actually read about it. Drop columns which contain missing value. Only a single axis is allowed. So just read through it and drop na. So if I do axis equal to 1, currently we do not have any columns, but you could do this as well. We are almost at the end of the video. Just one more very useful thing that I wanted to share with you guys. So you could also group by something, like for example, I want to group by gender. And what happens with this is that now you can see the stats for like particular genders. Here we have 2 genders, female and male. So what you could do is you could iterate over those 2 groups, like female group and male group. You could also do transformations for that particular group or see the stats. So actually, let me give you some examples. So if I do like a simple count, what will you see? You will see general everything, right? Now look at this, how interesting it gets and how useful it gets. So what I'm going to do is for both the genders, show me the height, and then why don't you find me the mean height for females and mean height for males, right? Or why don't you find the median weight for me, right? So I can just go to weight and go to median, or like this you can go to standard variation, or if you want to find multiple aggregations you can do that as well. Suppose I do this and I go to aggregate and I can mention the multiple aggregations that I want. Like for example, I want sum, I want mean, okay? And let's actually see this and you can see. And you can also mention over here by giving colon that exactly what you want, so it can like come out in a good way as well. So you can use the stats like this. This finally brings us to the end of the video. Guys, if you have watched it here, I am just so damn proud of you. This really means you are very, very serious about machine learning, and thank you so much for trusting me with your learning process. As I said in the beginning also, there is so much more to Pandas. Obviously, it's a huge library, okay, and it's very, very powerful. You can learn about a lot more transformations and so much more. In fact, see, Matplotlib is known for visualizations. There are some basic visualizations that you can do using Pandas. You can do normalization using Pandas, which scikit-learn is known for, right? So there are a lot of things that you can do using Pandas, but this is more than enough for you to get started with any of the projects out there. So I hope this helped. If you are a complete beginner, let me know if you want me to talk about any of the topics in a lot of detail. If you're someone who used this video for revision, let me know if I missed out on something or if you would like me to create a dedicated video on any particular topic. I would love to do that. And we have so much more content coming up, especially machine learning related. I think I want to focus on that this year, especially 2025. My major focus is on machine learning. And that brings me to the point that our hands-on generative AI course is starting soon. It's a live course and we are doing 10 hands-on projects, like big and small, as I've said earlier as well. If you're interested, at least like check out the details, and if you're interested, like please don't miss it. It's going to be live. It's going to be so much fun. And I hope that you will be part of it. And see you next time, guys. We have so much to cover. We'll be covering NumPy, Matplotlib, we'll be covering TensorFlow, Keras, we'll be covering scikit-learn. We'll do like this 1-hour videos for everything. So please do let me know your feedback in the comment section. If you could share the video with your friends, that would mean the world to me. And so many of you have still not subscribed, so if you could do that, it would be like, it would really motivate me so much. You have no idea. Okay, I'm going to stop talking now, but you get the point. It will really mean a lot to me. All right, see you guys next time. Bye.